Hi class, this is our first video lesson. Today 17th of March, we'll be working with, in the class we almost finished vectors. I just want to go through a few questions from the chapter review and then I'll give you a worksheet to solve from vectors, and the next video definitely will be from the next chapter, dynamics. Okay, let us take a few questions from the chapter review. Now this is in your book, chapter review, question number 6. Okay, now what I want you to do is, like in the class, when I give you a question, first I ask you to solve on your own. So you take some time to solve and then we discuss, correct? So what we do now here is, you pause the video now, go through this question, try to solve it, and then we will discuss. So you can pause the video now. Okay, hopefully you would have paused it and solved. Let us go through the question now. See, first of all, the question says a small boat S is drifting in the seas, modeled as a particle moving in a straight line at a constant speed, a constant velocity. Okay, at 9 o'clock, they gave you the initial position. See, I've written down the informations here. Let me get the pointer here. Okay, so at 9 o'clock, they gave us the initial position. I made a note here. For part A, we know the initial position. I just refer to it as IP. Final position FP is also written there. But remember, this is when T is 40 minutes. At 9:40, this is the final position, not always. And now, for part A, the question says calculate the bearing on which S is drifting. See, definitely drifting is the path of displacement, correct? And we studied in the class, for displacement we just do the final velocity minus the initial velocity, which is done here. So now we know that it is drifting 6I minus 2J. So 6 right, 2 down. This is the path in which the particle is traveling. And we know how to find the bearing. We studied in the class. In this case, tan theta, opposite over adjacent, and hence you get that 18 degree. Okay, so bearing will be, bearing is angle from north. So this 90 plus that theta gave us the bearing of 108. Let us go to part B. Now part B, they're saying find the expression of S in terms of T now. Remember, now the time is not 40 minutes. Time is just T. But what we clearly know from part A, we know initial position, we know final position, we know time. So with this three information, we can find velocity at which this boat is drifting. Let us go to the next slide. So yes, we have initial position, final position, and the time it took to reach from here to here, 40 minutes, which is 2/3 of an hour. If I use that IP, time, and FP in this velocity formula we studied in the class, velocity is FP, the final position, minus initial position, which is nothing but the displacement. So velocity is displacement divided by time. You just substitute, you get the velocity. Now definitely in the question they said it is going with the constant velocity. So whether it is part A or part B, the velocity is going to be same. And now for part B, they said find in terms of time T. The initial position is definitely, we know, time is T, because they said after T hours, and we got the velocity also. Now remember this formula we studied, it's the same formula rearranged basically. So FP is velocity, you cross multiply velocity into time plus IP, you just substitute the values, you got the answer. So this is the answer to part B. We got the final position in terms of time T. Let's go to the next slide. Now the third part of the question says at 11 a motorboat M leaves O. In the question they said O is origin, so we know it is 0I plus 0J, and travels with the constant velocity. Now we have to find the velocity basically. Now given that M intercepts S as at 11:30, so definitely we know the intercept, so definitely the final position of both M and S at 11:30 is same. So what we can do is we can find the final position of S at 11:30, and definitely that will be same as the final position of M. Now for S we have this formula, and now because S started at 9 a.m. from 9 to 11:30 it's 2.5 hours, and that is why in place of T we just substitute 2.5. We got the final position of S, which is definitely the same as final position for M. And here, now for M we know the initial position, we know the final position because it is same as the final position of M, and time. Now for M It started at 11 o'clock. So from 11 to 11:30 for m, the time is just 30 minutes, which is 0.5. So now velocity, final position minus initial position over t. Now this is the question from one of the past position minus 0 over this. We'll do the same thing like 49i said before, minus 23j, which was the question. They wanted us to find velocity. Try to do this question on your own first. P is 41, and then we will discuss. And Q is pause the video now. 23. Clear? Okay. Let us go on to the next question. I hope you would have tried it. Now the question says a particle of mass is given 0.5 kg moving under action of single force. So we know force, we know mass. They want you to find the magnitude of acceleration. The formula for acceleration and mass, correct? F equals to ma. Substitute, we know the force, we know the mass. You just simplify this, you get acceleration. Because they want magnitude, you do square root, that formula we studied. A square, the Pythagoras formula. And we got the magnitude of the acceleration. Part A. Part B, the question says at time equals to 0, initially the velocity is given. Find the velocity of P at time t equals to 2. Obviously, we're talking about initial velocity, final velocity and time. And we studied this formula in kinematics, v equal to u plus at. You know the initial velocity, you know the acceleration from here. You know the time. And you know the acceleration. You substitute, you get the answer for velocity. Part C, they're saying another particle q moves with a constant velocity. Okay, find the distance moved by q in 2 seconds. Again, distance is just 2 magnitude of v here, and that's why it's 4.47 meter. The last question says show that at time t equals to 3.5 seconds, both particles are moving in the same direction. Again, we discussed this. Same direction means parallel. And if two vectors are parallel, they should be a multiple of each other. So let us see if it is a multiple of one is a multiple of the other. So when t is 3.5, the velocity is just substitute in the formula and you get 22i minus 11j. If you take 11 as a common factor, you get 2i minus j, which is same as this. You see 2i minus j, and this is 11 times of the same thing. So definitely one is a multiple of the other, so they are parallel, hence in the same direction. Let's move on. See, in your textbook, this concept is actually taught in chapter 4 in dynamics, but because it is related to vectors, I am taking it now here. This question says the particle is in equilibrium under 3 forces. Now definitely equilibrium means resultant force should be 0, and now because there are 3 forces, the sum of the 3 forces should be 0. So if you solve, F3 should be minus of F1, F2 goes on the other side, you just substitute and you get the force. Equilibrium, resultant force is 0. Question now, the same question is asking you to find the magnitude of F3 and the angle it makes with the x-axis. Same magnitude we studied, it is nothing but the Pythagoras, it's square root of 2 square plus 5 square. And angle, again, you can draw a triangle. It is going 2 right, 5 up. 2 right, 5 up. So you tan theta is opposite over adjacent and you get the angle. Try to solve the other one as a homework. Both the slides, the previous and this one. Let's move on. Okay, a similar question now. They're saying there are 3 forces acting on a particle of m kg. Where for question part C, I have solved only part C here. They gave you the 3 forces and the mass, and obviously resultant force is the sum of all the forces. So we know the resultant force is the sum of this P force plus Q plus R, and that gives us the resultant force. And we just put in the formula F equals to ma. We know force, you know mass is given here, and you got the acceleration. These are simple concepts. And now this is from one of the past paper. Now this is your task. I want you to solve this question on your own. And then in my next video, I'll explain. I'll give you the answer. I'll make a worksheet and send in the group, and you can check. What I want you to know is this part which I've made in this box. You should know this. When they're saying B is due south of A. See, south, if something is north south, definitely they're talking about vertically up above each other. Okay. So if they're vertically on the same line, vertically south north, they have the same I component. Similarly, so you just have to equate the I component. Similarly, if they talk about east-west, if the objects are east-west, they are horizontally on the same level. So they will cut the y-axis. So they have the same j component. This is point number 2. Point number 3, sometimes they say makes an angle of 45 degree. Now see, a line making an angle of 45 degree like this definitely means gradient is 1, which means it is moving the same distance on the x-axis and the same distance on the y-axis. So in other words, the gradient is 1, or I can say the I component equals to the j component. So when it makes an angle of 45 degree, something like, if they mention something like that, you just make I component equals to j component, and that's it. This was our first video. I know it is a bit long. Let us see how it goes. I'll come up with the other videos for the other chapters soon, inshallah. Signing off. Goodbye.